Okay, so we have talked about polynomials a little bit. We were working on them all last week. We know something about the end behavior. How do you know what the end behavior is going to look like?
Whatever direction you graph.
Yeah, you look at the degree and if it's a positive or negative coefficient. We know that the zeros are what on the graph? The x-intercepts. Now the problems I gave you last week, either I gave you the factored form and asked you to graph it, or I gave you the first zero and you had to factor it. If I gave you the first zero, how did you factor it? What did we have to do? Yeah, how did we get there? What did we do first? If I said, here's a polynomial and 2 is a 0.
Are you recording?
We did synthetic division with the 2 first.
Nobody's here.
Come in. So we started with that. Thank you so much. All right, so today I want to talk about what do we do if I don't give you that first 0 to start with. And this is where the rational zeros theorem comes in. Now, it does not give us every 0. It only gives us the rational ones, so the nice ones that can be written as a fraction. Any imaginary zeros or zeros that might have a radical in them, this isn't going to help. But it gives us that starting point if I don't tell you what the first 0 is. It tells us every 0 will be of the form p over q, where p is a factor of the constant and q is a factor of the leading coefficient. So let's take a look at this example. All right, I want to list all the possible zeros to start. So that's everything that could be a 0. Not necessarily everything that is, but just what are my possibilities? Okay, this polynomial isn't divisible by everything under the sun, so what could it be? So we start with p. To get our p value, we look at the constant. What's everything that evenly divides 6? Exactly. Now, to get a negative 6, could I do positive 1 and negative 6? Or negative 1 and positive 6? So we can agree that these could be positive or negative. So my p's will be positive negative 1, plus or minus 2, plus or minus 3, plus or minus 6. Q comes from the leading coefficient. So if I have a 2, what is everything that evenly divides 2? And again, to get a positive 2, we could have positive 1, positive 2, or negative 1, negative 2. So they still get the plus and minus. Now, to get my possible zeros, we do p divided by q. And because we have every combination of positive and negative, we will continue to put the plus and minus on everything. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. 2 divided by 1 is 2. 2 divided by 2 is 1, but I already have that on my list, so I'm not going to put it again. 3 divided by 1 is 3. 3 over 2. 6 over 1 is 6. And 6 over 2 is 3. Which I already have, so I'm not going to list it again.
Please, this is the answer.
This is the first part. Listing the possible zeros. Here's everything that could work. Now I need one that does work. So how will I know if something works? When we plug it in, what should it equal?
0.
0. Okay, find me one that works. Plug these in. Get
Sam, you
something that
take one,
equals
one
0.
half. You agree? Everyone else agree too.
I would recommend trying to avoid the fractions if possible. It's not always an option, but they are uglier. So I would start with my integers. And we don't need all of them, we just need one that works. Which one? All right. Now we have the first 0. So it's back to last week. When you have the first 0, what do you do?
Division.
Yeah. Because it's time consuming to plug all of these in, and we know if it's an imaginary or something, we're not going to get it anyway. So we don't just want to plug in every number. We want one that works, and then we can start dividing. So if we do this synthetic, and we get to this point. What do we do here?
I don't know.
We need to factor. Yep. So multiply 12 and add 13, that would be 12 and 1. Have to divide by 2. So we get x plus 6 and 2x plus 1. What else do I need in my factored form? We said we already divided by 1, so x minus 1 is the last zero. Or the last factor, excuse me. What are my zeros?
-6, -1/2, and
Were all of those on my list of possible zeros?
the
They were, and you could have started with any of those and gotten the correct answer at the end.
So it's what we did before. We're just applying these now.
Yeah, I'm just not giving you that starting point. You have to figure it out yourself. Is that one okay? Let's try another one. So we have to start with our possible zeros. So we need the p's and q's. So p is everything that goes into the constant. What goes into 2? Good. And q is everything that goes into the leading coefficient. So same numbers as last time, but I flipped which one was p and which one was q. So possible zeros, we do p over q. We always have to do plus and minus on everything. So we have 1 over 1, 1 over 2, 1 over 3, 1 over 6, 2 over 1 is 2, 2 over 2 is 1, I've got that, 2 over 3, 2 over 6 is 1/3, and I've got that. So now I need one that works.
Okay.
Another shortcut, another option for finding one that works. You guys have a graphing calculator, right? We know that if it's a 0, when you plug it in, it equals 0. What else could you look at on your calculator?
X-intercepts.
The x-intercepts. Graph this real quick. Go to your y equals and graph that equation. And then you just have to tell me a place where it hits the x-axis. Now, I would again be leery of fractions because it's hard to tell exactly, but any of those integer values you can kind of tell. So we said that 1 worked. If you look at the graph, does it appear to hit the x-axis at 1? So I don't care if you get it by plugging the numbers in or by looking at a graph. You just somehow need to be able to find that first 0. But I will expect the work. I will expect to see the p's, q's, and possible zeros on everything. So, no shortcuts. We can start our division. So looking at this, are we ready to just factor? No. So we need to find another one. Now, all of your possible zeros still work. We just need another exact one. So look at your graph. What x-intercept do we have? Hmm?
I tried the intersect option and I somehow failed.
Yeah, it won't. You have to have two
Yeah,
equations
negative
to use intersect. Is there a nice like integer value? Does it hit -2 maybe?
One second. Decided starting up at -40. -2 does work.
And you can tell that from the graph just by looking at it.
If you go to second and graph for the table, much easier.
As long as your table function hasn't been messed with, because sometimes those might give you decimal instead of counted by integers. Okay, so again, you can't just rely on that. You're using that to get your first point, and then you have to have all the work to support it. So we do this division with what we just got out and the -2. And we get 6x squared plus x minus 1. Now what?
Factor.
So if we do slip and slide. Okay, so it's x plus 3, x minus 2. Divide everything by 6.
So did your screen originally do that?
What?
Thing on the side.
Oh, it's my recorder.
I know, that's why I'm asking, because I don't remember it doing it the
I
last
usually record earlier in the day, but it crashed during my class this morning, so I lost my recording.
time. That's the last time you recorded that didn't pop
It
up.
depends on how I didn't get my window wide enough. If I get it wide enough, you can't see it.
I blame that.
So my factored form, what else do I need in here?
We also used 1.
And we also used 1, so we also need an x minus 1. So my zeros, this was an x to the 4th, so I should have 4 zeros, and we do. Be -1/2.
Oh my god.
All right,
It's gonna be a
so far so good?
Yep.
Do we need more?
Nope.
So the bigger the degree, the more the work.
Exactly.
Yay.
That's awesome.
All right, do you guys want another one?
No?
Is it?
Was this all related?
Mhm.
Okay.
Okay.
Do we have homework?
There is a Math Excel assignment